Hello everyone. Today's topic is solution of ordinary differential equation using Laplace and inverse Laplace transform. Okay, and remember this is the last topic of your module 3. That means Laplace and Laplace inverse transform. This is the last topic. So when you have to solve any ordinary differential equation using the concept of Laplace, you have to remember two formulas. Okay, two formulas of Laplace transform of derivative. Okay, the first formula is Laplace of f dash t. You already know this formula. Laplace of f dash t. This is equals to s fs minus f of 0. Okay, and second formula you have to remember Laplace of f double dash t. This is equals to s square fs minus s f of 0 minus f dash 0. Okay, because in your syllabus you have the equations up to second order. Okay, so just you need these two formulas. Clear? I already have told you the what is the general formula of Laplace transform on derivative, Laplace of f and t. Okay, so but in this question or in this topic just you need these two formulas. Here in this part you have to solve this type of questions by three methods or three steps. First step is step 1. Step 1 is first you have to identify which one is dependent variable or which one is independent variable. Obviously in maximum question y is given and y is our dependent variable. Okay, so first you have to consider that Laplace of yt. I am taking y is our dependent variable and t is our independent variable. Okay, so first you have to consider that Laplace of yt, this is equals to ys. This is the first step. Okay, now second step is you have to apply. Actually you will be given a differential equation. Let's say the given differential equation is d2y dt2 plus p dy dt plus qy. This is equals to let's say r. Okay, non-homogeneous ordinary differential equation. So here obviously here the dependent variable is y and the independent variable is t. Okay, so first you have to take Laplace of yt. This is equals to ys. Now second step is you have to apply Laplace transform to both sides of the equations. Okay, so apply Laplace to both sides of the equation. This is the second step. Okay, so when you will apply Laplace transform to both sides of the equation, obviously you will get y of s. Okay, after simplifying you will get y of s. This is equals to something you will get. Okay, after applying the Laplace transform. Now but condition is you have to solve the equation. Solution means you have to find out yt. Okay, and you have gotten ys. Now if you apply Laplace inverse on ys, obviously you will get yt. Yes or no? Because already you have taken Laplace of yt. This is equals to ys. So after third step, if you apply Laplace inverse, you will get ys. So third step, so fourth step, step number 4, you have to apply Laplace inverse on ys. Okay, obviously all these steps are in equation form, so obviously you have to apply Laplace inverse to both sides of the equation. So here you will get y of t. Clear? So these are the 4 steps. First you have to consider that Laplace of yt equals to ys. Then you have to apply Laplace transform to both sides of the equation. Then after simplifying this, you will get ys. Now step number 4 is you have to apply Laplace inverse. Okay, but let me tell you these 3 steps Step number 1 to step number 3. These three steps are very easy. But problem is step number 4. You have to calculate this Laplace inverse. Okay, and it is totally depending on your practice. Okay, so I will solve only one problem, because it already you know how to apply Laplace transform, how to apply Laplace inverse transform. It's totally depending on your practice. Okay, so let me solve only one question. So first question, solve by Laplace the differential equation. The equation is d2y dt2 plus 2 dy dt plus 5y equals to e to the power minus t sine t. Solution. Achha. Here you have given two conditions, because this is second order differential equation. So obviously you will be given two conditions. Okay. The first condition is y0, this is equals to 0, and y dash 0, this is equals to 1. Now solution. Step 1 is, first you have to consider that Laplace of yt, this is equals to ys. So let Laplace of yt, this is equals to y of s. Okay, then you have to apply Laplace transform to both sides of the equation. So applying Laplace to both sides of the equation, comma, we get. So if you apply, so you are getting Laplace of, this is d2y dt2. So in place of d2y dt2, can you write y double dash t? Yes or no? Obviously you can write. So I am writing Laplace of y double dash t. Okay, plus 2 into dy dt. That means 2 into Laplace of y dash t plus 5y. That means 5 into Laplace of yt. And this is equals to Laplace of e to the power minus t into sine t. Clear? Now, according to the formula, what is Laplace of y dash t? Very simple. S square ys minus s into y0 minus y dash 0. Clear? Okay. Plus 2 into Laplace of y dash t. Y dash t means s into ys minus y of 0. Okay. Plus 5 into Laplace of yt. And what is Laplace of yt? Ys. So 5 ys. This is equals to. Now Laplace of e to the power minus t sine t. So first tell me what is the Laplace of sine t? 1 by s square plus 1. And here e to the power exponential multiplied e to the power minus t. That means you can apply first shifting property. So e to the power at multiplied. So s will be replaced by s minus a. So here a is equals to minus 1. So s will be replaced by s plus 1. So the result will be 1 by s plus 1 whole square plus 1. Clear? Now just you have to simplify this. So or s square ys. Now tell me what is the value of y0? Y0 equals to 0, na? So you can write in place of y0, this is 0. That means this term is neglected. Yes. Now y dash 0, this is equals to 1. So you can write s square ys minus 1. Clear? Plus 2 into sys minus y0. Again, y0 equals to 0. That means just you have to write 2 into sys. 2 into sys plus 5 ys. This is equals to 1 by, if I simplify this, so this will be s square plus 2s plus 2. Okay, s square plus 2s plus 2. Now from left hand side, take common ys. So you are getting ys into, in bracket you are getting s square plus 2s plus 5. Yes or no? So also you have another term. This is minus 1. This minus 1. So you have to write minus 1. This is equals to 1 by s square plus 2s plus 2. So take this minus 1 on right hand side. So or s square plus 2s plus 5 into ys. This is equals to 1 plus 1 by s square plus 2s plus 2. And this is equals to s square plus 2s plus 3 divided by s square plus 2s plus 2. So finally, what are you getting? Ys is equals to, the numerator is s square plus 2s plus 3 and the denominator is s square plus 2s plus 2 into this term s square plus 2s plus 5. Okay, so step number 3 is completed. Okay, yeah, this is our step number. Sorry, this is ys. Step number 3 is completed. Okay, now you have to apply Laplace inverse. Here you have to apply Laplace inverse. So let's say this is equation number 1. Now here you can see that each term is containing s square plus 2s. Yes or no? S square plus 2s. So I can write this in the form of s plus 1 whole square. Yes, we can write it in the form of s plus 1 whole square. So okay, let me write applying Laplace inverse to both sides. So Laplace inverse y of s, this is equals to Laplace inverse s square plus 2s plus 3. So obviously we can write it in this form s plus 1 whole square plus 2. Yes, s plus 1 whole square plus 2. Similarly here s square plus 2s plus 2, we can write s plus 1 whole square plus 1. Yes, into s square plus 2s plus 5, that means s plus 1 whole square plus 4. Clear? So here you can see the term s is replaced by s plus 1. The term s is replaced by s plus 1, and this is possible when e to the power minus t is multiplied. Yes or no? If e to the power minus t is multiplied, s is replaced by s plus 1. So next line we have to write Laplace inverse y of s. This is equals to e to the power minus t Laplace inverse of, so s plus 1, that will be replaced by s. So you are getting s square plus 2 divided by s square plus 1 into s square plus 4. Okay, so this is equals to e to the power minus t. Now partial fraction, so we can write it in this form: s square plus 1 and s square plus 4. That means a by s square plus 1 plus b by s square plus 4. Okay, so you are getting a plus b s square plus 4a plus b. Clear? And the denominator, that will be equal, and this is equals to nothing but the numerator s square plus 2. I hope you know how to find out the partial fraction. So if you compare, you will get a plus b, this is equals to 1, and 4a plus b, this is equals to 2. So after simplifying, you are getting minus 3a, this is equals to minus 1. So you are getting a is equals to 1 by 3. And if a is equals to 1 by 3, so from here, from a plus b equals to, on this equation, you will get b is equals to 1 minus 1 by 3. That means b is equals to 2 by 3. So a is equals to 1 by 3 and b is equals to 2 by 3. Clear? So put these values. So you are getting Laplace inverse of a is equals to 1 by 3. That means 1 by 3 into s square plus 1. Okay, plus b is equals to 2 by 3. That means 2 by 3 into s square plus 4. Now 1 by 3 is common, so e to the power minus t divided by 3, Laplace inverse of 1 by s square plus 1 plus 2 by s square plus 4. So from here you are getting e to the power minus t divided by 3. Now Laplace inverse of 1 by s square plus 1. That means this is equals to this is s square plus 1. Okay, so this is sine t. Yes, sir. Laplace inverse 1 by s square plus 1 sine t, and this is 2 by s square plus 4. That means sine 2t. Okay, and this is here y of t, because left hand side is Laplace inverse of y is, that means this is your y of t, and this is the solution. Yt is equals to e to the power minus t divided by 3 into sine t plus sine 2t. Clear? So in this way, you have to solve this type of ODE problem. I am giving you two problems. Try to solve this. First question. I am writing just the differential equation. Y double dashed plus 9y. This is equals to 6 into cos 3t. Okay, and given y0, this is equals to 2, and y dash 0, this is equals to 0. Second question, solve y double dash minus 3y dash plus 2y. This is equals to 4t plus 3 e to the power 3t. And here given y0 equals to 1 and y dash 0, this is equals to minus 1. And try to solve this one also. Y double dash minus 4y dash plus 4y, this is equals to 64 sine 2t. Okay, and the initial conditions are given: y0 equals to 0, y dash 0, this is equals to 1. Okay, I am writing the answers also, or in first question the answer is y is equals to 2 cos 3t plus t sine 3t. Okay, and in second question the answer is y is equals to t plus 2t plus half into e to the power 3t minus e to the power t minus 2 e to the power 2t. Okay, and in third question the answer is y is equals to minus 8 e to the power 2t plus 17t into e to the power 2t plus 8 cos of 2t. Okay, so try to solve these questions. I hope Laplace and inverse Laplace transform is now very easy to you. Try to complete all the lectures from my playlist, all the lectures of Laplace and inverse Laplace transform, then solve your question then. Okay, definitely you can score minimum 20 to 25 marks out of 30. Okay, because in module 3 you will get maximum 30 marks. Okay, 25 to 30 marks from module 3, and obviously you can score minimum 20 marks. Okay, thank you so much.